Today, mobile cranes are of utmost importance in the construction industry. They are as fast as a truck, multifunctional, and are teeming with power. The construction of bridges, high-rises, or windmills is no longer thinkable without mobile cranes. And here in Bavaria, the Tadano company has created a new challenge for itself: the construction of the world's most modern 400-ton mobile crane. When developing a crane, there are two main focal points. Those are the load capacity of 400 tons and, of course, the crane's own weight. You can immediately begin to put the crane's functions into action, immediately deploy the outriggers, load on the counterweight. From 1 million theoretical load conditions, we simulate around 20,000, and 20 to 30 of those will be explicitly tested. From the 20,000 load cases, we are later able to derive the structure of the frame. That means we know how strong each piece of sheet metal at each position has to be, and apply the rule as light yet as strong as possible. In conclusion, one can say that we've fulfilled the weight standards, the power expectations, and can realize the requirement for speed on the highway as well as on the construction site. The success of the engineers surely has to do with the company's over 160-year-long tradition in building vehicles. Through this tradition, they were able to gather an enormous amount of experience by building diverse vehicles. It all began at the end of the 19th century with the construction of fire trucks under Justus Christian Braun. The result of this tradition was company vehicle plants in Ansbach and Nuremberg, Faun for short. These plants enjoyed their greatest success by building semi-rigs, garbage trucks, fire trucks, and mobile cranes. The product range was then expanded with other various construction vehicles. Early in its history, Faun oriented itself on international markets and delivered, for example, dump trucks and heavy load transporters to Russia. There, the plant was able to decisively support the development of gas and oil fields in Siberia. This German-made technology allowed the expansion to be accelerated and the energy supply throughout much of Europe to be supported. Since the 1990s, the plant works under the name Tadano and specializes in the construction of highly modern mobile cranes, such as their flagship model, the ATF 400. In multiple buildings, over 12 different types of cranes are produced. One of them is the new ATF 400, which is meant to become a milestone in its class. For over 2 years, the engineers have fiddled with this giant, and now the time has come. Under the guidance of plant manager Klaus-Peter Grabe, this vehicle, which weighs over 70 tons, is being assembled. Here we are at the start of assembly at 0 hour. In this hall, the chassis will be mounted. The quality of the frame will also be checked and finally clamped in place before assembly begins. The 0 hour marks the birth of this mobile weightlifter. The 17-meter-long frame doesn't just have to carry its own weight of 72 tons, but also the maximum operational load capacity of 400 tons, as well as 138 tons of counterweight. The demands on the processing and quality of the steel are accordingly high. In their welding shop, Tadano secures its own expertise for the production of extremely high-quality steel. One quickly realizes that in comparison to automobile production, the production here is on a complete other dimension. In order to continually optimize the quality and production processes, Wolfgang Kammerer is active on all production lines. For the ATF 400, we have an axle load of 12 tons per axle. These 12 tons have to also be braked. This braking is ensured by a compressed air tank, which keeps sufficient air pressure at the ready, so that during emergency braking, the necessary brake force is available to bring the crane to a full stop. One must also understand that 12 tons, in comparison to a normal automobile, which carries only 700 kilos per axle, are of course much more weight. For this reason, we also have special hoses, which ensure that the crane can immediately brake at any job site. The construction of such a vehicle is not only a technical challenge, but also a logistical one. In addition, the timing of the individual stations has to be coordinated with one another. Every 8 hours, the production assembly line moves. Every 8 hours, the technicians have to have the preparation of the parts as well as their installation finished. Every 8 hours, a new frame is clamped in at 0 hour. Like clockwork, the individual steps and construction phases flow into one another. The axles merit particular attention here. This is the axle pre-assembly site. Logistics delivers to us all the necessary parts on time. The employee sorts the parts, be they the hydraulic cable, the steering cable, the central lubrication system, or even push rods. He then prepares the axle for installation onto the frame in order to turn over the axle, which is then ready for installation to his colleague, who performs the actual installation. Here we are at the axle installation site, where the axles will finally be installed. For this, the fitter utilizes the ceiling crane. Using the ceiling crane, he brings the entire axle and all connections into position and connects the push rod with the frame. The push rods, which also move synchronously with the axle through suspension, serve as connectors between the axles. Every mobile construction crane is made up of an undercarriage with its cab, which is responsible for transporting and maneuvering, and the upper carriage, which controls the boom and the actual crane work. This way, both elements have their own units. Now we're at the motor installation area. Here is where the motor for the undercarriage is set into the frame. Here, it is important that the clearances are properly maintained, because there are only millimeters to spare when the block is steered past the frame elements. It is also important that the frame is built so that it not only works structurally, but that the production goes smoothly. That way, the fitters can relatively economically and quickly install the motor on the assembly line. After the installation of a 653 horsepower engine, the cab is finally assembled. For the first time, one gets a real impression of the size and form of the vehicle. This is the assembly stand for the wheels. The ATF 400 will be assembled with 6 wheels on each side. An interesting feature is that here we have powder-coated rims with inset nuts, which means the nuts won't loosen because of the heat generated by the axle. Instead, they will remain fixed in position. During the wheel assembly, special technology comes into play. In order to withstand the extreme loads on a daily basis, the nuts are screwed into place using a hydraulic screwdriver. After all 12 wheels are mounted, the vehicle is brought to life. With the first ignition, all axles and their technology are tested for functionality. Only the outriggers for stability are missing now. During the outrigger pre-assembly, the outrigger cylinders are installed into the outrigger boxes. The ATF 400 has 4 outrigger cylinders that support it during use. And here you can see how they are set into the outrigger boxes. With other cranes in this class, the outriggers have to be specially transported and then assembled. The ATF 400 always carries these guarantees of stability on board, which allows it to be put into action much quicker. Here is where the pre-assembled outriggers are mounted onto the chassis of the undercarriage. This is the outrigger cylinder, on the bottom of which the foot will be mounted. The foot then presses against the ground and supports the crane. The upper carriage is assembled at the same time as the undercarriage. This is the beginning of the assembly of the upper carriage for the ATF 400. At this workstation, the sprocket is placed into a device, especially built for its assembly. Here, 3 main components will be assembled. Those are the sprocket, the slewing gear, and the lubrication system. This sprocket has to bear enormous loads of well over 500 tons, but also hold its position against strong radial forces when the boom is extended. It is the joint between the upper carriage and undercarriage, and the screw connections are laid out with the chassis accordingly. That is the undercarriage frame being delivered just in time. Of course, it has to be especially rigid and built from special steel. Here, you can see the needed open compartments and devices, such as here for the engine, or there for the cabin. This is the frame for the hoisting winch. The load line will be installed here and later used to lift up the payloads. Here is where the bolts for the boom will be placed, and here in the middle is where the boom for the crane will later lay. The technicians need their full concentration at this moment. Our specialists will now lift the frame onto the device. Here, of course, the utmost care and accuracy is required. You have to imagine that the frame weighs 4 tons, which is about the same weight as 4 VW Golfs. This screw alone weighs 600 grams, and the sprocket is fastened onto the upper carriage with 82 of them. So one can already begin to recognize the dimension and weight ratios. Now the upper carriage engine will be fit with the hydraulic pump that is being delivered just in time. The frame of the upper carriage has already been prepared by the fitters for its installation. And now the engine can be positioned. The hydraulic pump is responsible for supplying hydraulic fluid to the entire technology of the upper carriage, be it the boom or the slewing gear. The hydraulic fluid is guided via the hydraulic tank to the pump, and there it is pumped with up to 400 bar to the individual distributors. The installation of both engines for the upper carriage and the undercarriage is straightforward. In just a few steps, the powerhouses are connected. The connection of the innumerable cables, hydraulic hoses, and plug-in connectors are more complicated and demanding. The mechanics have to work with utmost care. This is where the brain of the crane is connected to the individual functions, such as the winch for the load line. The winch is operated using a hydraulic motor. The hydraulic motor is designed to hold, raise, or lower great forces, but also to sensitively operate the winch, which means to wind or unwind it. Here you can see the hydraulic tank. The tank has a capacity of 1,800 liters and provides the entire upper carriage system with hydraulic fluid. When all hoses are connected, the engine and the transmission are made ready. At our very own gas station, all necessary hydraulic transmission and motor oils are filled up. About 800 liters are necessary to have the super crane ready for action. The safety caps are easily recognizable. The caps are present on all parts of the hydraulic system and are delivered as complete components. On the assembly line, the fitter then takes both safety caps off and connects the individual elements. In this way, it can be guaranteed that no dirt enters the system at any time. Now the control cabin for the upper carriage is arriving, from which all movements of the crane will be controlled. Here is where the upper carriage cabin is mounted. The upper carriage cabin is the central control unit of the crane. The upper carriage cabin has 2 joysticks, which can exactly execute all movements of the crane. In just a few steps, the cabin is installed onto the upper carriage. Now we find out whether all the lines and cables have been laid correctly. With the computer simulator, various processes and scenarios are performed without the crane actually being put into action. This way, possible mistakes can be discovered and quickly fixed. With our test bench, wire harness tester, and different sensor cables, we have the possibility to simulate various load conditions and then make corrections or improvements if necessary. The ATF 400 is not only a powerhouse, but also a high-tech vehicle. Almost all of the functions are controlled from the touchscreen. Similar to aircraft construction, mechanical components and controls are completely replaced with electronic modules. Now we're coming to the highlight of every crane production, the so-called big marriage. Here, the complete crane is lifted with the help of these special lifting bands. The band alone can lift 15 tons. The additional chain can lift 20 tons. The upper carriage is then lifted and set onto the undercarriage. Different than in normal life, our marriages last practically a whole lifetime. The time has come. The multi-ton heavy upper carriage hovers over the production line and is set onto the undercarriage. Absolute precision is now needed because the men have to set the module exactly over the fixing bolts. Despite this being routine, the technicians are always a little tense during this process. First, the screws are lightly tightened using an air wrench and later completely tightened using a torque wrench. The torque wrench can apply about 1,400 Newton meters of torque. We could never manually apply that much force using a lug wrench. And once again, a made-in-Germany marriage has been performed, which is a guarantee for a long operating life on construction sites around the globe. Since our founding, innumerable vehicles have left our plant. The visions and patents of earlier designers and engineers represent a priceless wealth of experience on which the doers of today can build upon. The laws and values from that time have to be continually challenged and adapted to current market demands so that cranes can also be successfully built in the future. In every era of the company, the engineering skills were very influential and contributed to today's breakthrough on the ATF 400. Our engineers, technicians, and employees are proud to be able to maintain and expand this tradition. Here we are at the wheel alignment area. The technician is checking the exact spacing and correct dimensions with a laser instrument. This is where all data is brought up on the tablet and then checked to see which wheels need adjusting in order to be brought into the appropriate track. He will now perform this very task on every individual axle on the entire left side, as well as on the right side. Afterwards, he will go into the pit and perform the necessary adjustments. When all the axles have been measured, the super crane will have a final inspection and then be driven out of the first production hall to be prepared for the assembly of the big boom. The 60-meter-long boom is teeming with power. Two components are crucial here: lightweight and stability. That means the crane should be as lightweight as possible, but still have the ability to lift the largest payload as possible. The third factor is its variable length, which is designed using telescoping technology. We are now on the boom construction site. The boom is the heart of the mobile crane. You have to imagine the boom like the telescoping antennas that cars had earlier. When installed, it is rather small, but it can be extended for operational use. It is the same with the boom. The boom is made up of 5 parts, and when it is fully extended, it is 60 meters long. The assembly of the individual telescopes is also absolute precision work. Every one of these modules weighs several tons. The focal point is the cable pulley. Here we see the pulleys that have been mounted. The load line, which with the help of the pulleys lifts the payload, will later run through here. It is finally time. The ceiling crane will now mount the 5-piece boom onto the upper carriage, a decisive moment that demands the highest discipline from the specialists. Despite the enormous weight, the process looks almost easy. When the boom is set and all of the connections bolted into place, our super crane is as good as finished. The upper carriage and its boom have to deliver maximum performance, as does the undercarriage on a daily basis. Here, the brakes come particularly into focus because over 72 tons, or approximately 72 automobiles, have to be brought to a standstill. A crane shouldn't just be a crane. It should also drive well, in this case 85 kilometers per hour, following all safety regulations. It isn't just about the fact that the crane is mobile on the street, but rather that it is maneuverable in all situations on the construction site. That means that we need a tight radius, in this case 12 meters, and we need the lateral portability. That means the wheels are all individually steered and controlled. And all of that is a tremendous challenge, because during the construction of this technology, we naturally have to think about the weight. This design goes well beyond the construction of a regular truck, but we have once again been successful. Before this steel giant goes into service, it will be tested in all driving situations on the company's own test site. Bench testing is one thing. However, through practice, we can see in real terms whether all components, modules, and control units can function smoothly in all weather conditions and extremes. The undercarriage is brought to its limits through various driving situations. Later, the entire crane has to show on a different test field whether it delivers what the engineers promise. Here, at Tadano, various models of cranes are tested daily in different stress tests. On the one hand, the cranes are tested on function and hoisting capacity, and on the other hand, we are already drawing conclusions at this site, which further our technology. Every crane should be the best of its generation, but new models will be developed that are lighter, stronger, and higher than the previous models. On the outdoor area, various lattice jibs are mounted onto the boom to demonstrate variable forces and loads. Fully equipped, the ATF 400 reaches a maximum height of 125 meters. If the crane successfully passes the tests, then it goes to the paint shop. The workhorse is not only exposed to the weather, but on construction sites also to soil and rocks. The paint job has to be accordingly robust and scratch-resistant. The new owners let their creativity run wild when choosing colors. The painters spray multiple layers on the 17-meter-long and almost 4-meter-high vehicle. 2 men are busy with this almost an entire day. There are no dip tanks here like in the automobile industry. Here in the paint shop, every crane receives its individual color scheme. After extensive preparation, the crane is painted 2 times and coated with a special blend. Even the top coat is a special design, which has the task to protect the crane from weather and other environmental influences during operations, as well as additionally giving it a high-quality gloss. For the entire paint job on our ATF 400, we need 80 liters of primer and 140 liters of top coat. In total, we need over 400 hours to completely paint the crane. After completion of all the work, every crane is marked with the Tadano logo. Finally, the time has come. The new ATF 400 from Tadano is finished and rolls out of the hall. With 6 axles, 72 tons, and 653 horsepower, it leaves the production area on the run. For over 2 weeks, the mechanics worked on this powerhouse. Innumerable hours were invested into this high-tech vehicle. Now, it's time for it to go to work. The convoy, complete with escort vehicles, is headed to the world's biggest trade fair for construction machines in Munich. We are naturally in a position with this crane where we have to prepare for the setup very well. We have many elements that have to be delivered at the same time. We cannot make any mistakes during setup because we just do not have the possibility to send the crane away again. Because other vehicles have already taken up their position on the construction site or here at the trade fair. There are no second chances, and when something does happen, then it's associated with enormous costs. The construction of a mobile crane is one challenge, but the setting up of this giant is yet another. 4 professionals as well as an additional crane are necessary to put it together piece by piece. Alone, 10 semi-rigs are used for transporting the 76-meter lattice jib, the 138-ton counterweight, and various lifting accessories. When this powerhouse drives to the site, it is escorted by an entire convoy. The men will be busy for 2 days until the crane with the lattice jib finally can be put into action. If the weather worsens and strong winds arise, they need even more time. These 4 are an experienced team. The crane gets its ultimate test with them. For the first time, this giant is put together outside of the factory site. Completely extended, the crane tops even the towers of Munich's Church of Our Lady by over 20 meters. But not only the height is impressive, the force that develops on the boom is imposing. The mounted lattice jib alone weighs several tons and still has to lift the actual payload. In order to ensure that this can happen, additional safety devices will be mounted to the construction so that we can move several tons at a height of 125 meters. The crane passed its initiation rite and can now get to work. We were able to finish setting up the crane at exactly the right moment, fully equipped. That means with the 78-meter luffing jib and the suspension system. And now, even our stress has slowly faded. Nobody is very effective alone. The installation only works as a team. Even logistics, with 10 semi-trailers, over 100 tons of counterweight and jibs, has to work smoothly. And that demands professional execution from the plant as well, so that the parts arrive at the construction site at the right time, and so that we can start on time. But we finished everything, and tonight, we can enjoy a nice cold beer. The ATF 400 is another example of the German art of engineering, as well as the label Made in Germany. With its innovative technology, the ATF 400 will set new standards over the next years at construction sites around the world, while in Tadano's plant, new visions for the cranes of the future are in sight.